Sine and cosecant are reciprocal functions. So we can write each of them as the reciprocal of the other one, which you've already done when you use your calculator. So sine of theta you could write as 1 over cosecant of theta. Here's that thing. Because it's the reciprocal of sine as cosecant, then you can write sine as. The way we did that on our calculator, there's no cosecant button on our calculator. The way we typed in our calculator is we wrote 1 over sine. I call these the reciprocal identities. So these first 6 here, I'm just going to write reciprocal. So cosine and secant are reciprocal. The way we type secant on our calculator is we type 1 over cosine. We have a cosine button, but sometimes it might be necessary to write cosine as 1 over secant. And tangent and cotangent, same thing. We can write tangent as 1 over cotangent. And hopefully we're then writing cotangent as 1 over tangent when we type that on our calculator. I wrote tangent and cotangent again because we can also think of tangent and cotangent instead of reciprocals of each other. We can think of them in terms of sines and cosines, because what's the ratio for tangent? Like when you're doing the unit circle, how do you do tangent? You do y over x, and in the unit circle, the y is just sine, right? And the x is just cosine. So another way to think of tangent, I'm going to kind of show you where it comes from. Tangent is y over x, but remember, in the unit circle, y is sine, and x is cosine. And even if you're not in the unit circle, the r's would cancel. Like y over x over r, the r's would always cancel. So another way to think of tangent is sine over cosine, which means another way to think of cotangent is x over y, which means we could think of that as cosine over sine. Then we also have these Pythagorean identities, and they all come from the fact that Pythagorean theorem, right triangle, this is all coming from right triangle trig. These aren't going to come up that often right now, but I'm going to go ahead and give them to you just so that they can kind of be in the back of your brain, so when we get to them in chapter 5, this will be there. The one that's always used way more than anything else is that you can say sine squared of an angle, well that's weird, right? Sine squared. It just means like sine times sine, plus cosine squared of an angle will always equal 1. There's a cool little proof to go with that. I know that was kind of scary to you, but think about in our unit circle, I'm going to just show you really quick. I drew any angle. What do we know the radius is in the unit circle? 1. And wouldn't this just be y? And wouldn't this just be x? And think about if you did Pythagorean theorem. X squared plus y squared equals 1 squared. X is cosine, y is sine. So that's why it works, right? So that's why we call these the Pythagorean identities. They come from Pythagorean theorem. So it's kind of cool to know that any angle that you have, if you take the sine value and you square it, and you add that to the cosine value, if you square it, it will always have 1. And then there's other two that we don't use as often. 1 plus tangent squared equals secant squared. That's true. I don't wonder if I have a just take it as like there. Question authority. Well, I don't have it up here with me that I have it right, so sometimes I'm like, oh, did I add right? Because sometimes I don't add right. Remember what was the other day, Jared, that I did wrong? I just added wrong, remember? I just added 2 angles. Yeah, that's right. I was and then the other one is 1 plus cotangent squared memorize these 3 things right now. Chapter 5, you will have to memorize them, and we'll talk about ways that you can remember what goes together. But I just wanted to show them to you. There's proofs for these 2 also that you could use using Pythagorean theorem. This one's probably the one that outside of pre-calculus class, like in calculus class, every now and again that comes up. And I promise in chapter 5 we'll use it so much that you will remember it. There. All right. The other ones are the ones that I really think. Okay. So let's do some. Oh wait, I forgot these. This always looks really scary. Right. Cofunctions of complementary angles are congruent. I like to say, but I wrote equal here. Cofunctions are trig. I didn't use trig values that go together. Sine and cosine are cofunctions. This one's the easiest one for me to show you because we know values of sine and cosine. So what is the, let me just do some side. What is the sine of 30 degrees? Sine of 30 degrees is y is 1/2. The complement of that, complement of 30 degrees is 60 degrees. Yes. So what is the cosine of 60 degrees? Here, 1/2, right? Isn't it 1/2? It's not a coincidence that they both equal the same thing. If you have 2 angles that add up to 90 degrees, if they're complementary angles, then their cofunctions will always have the same value, which means the sine of whatever angle you can think of will always equal the cosine of the complement. And that's what this is saying here, because they write it as 90 minus theta. But the sine of 90 degrees minus theta will always equal the cosine of theta, meaning that they're complementary angles. And the same thing is true if you switch it around. The cosine of 90 degrees minus theta will always equal the sine of whatever angle you can think of, which works out really well. We could do it for 30 and 60 and 45 because we know those values. If you have a calculator, you could also do it for any angle, like angle that's terrible, like 50 degrees. So if I said the sine of 50 degrees, I don't know what that equals, but I know it's going to equal the cosine of, what's the complement of 50 degrees? 40 degrees, because 50 plus 40 degrees. And you can check, if you have a calculator, type in sine of 50 degrees and cosine of 40 degrees, they're going to be exactly the same thing. And it's because in a right triangle, right, those 2 angles that add up to 90 degrees to be the non-right angle, their opposite and adjacent sides just switch, so that's why that just works every time. So you just need to know that sine and cosine go together, and then you know that their complements add up. On my Math 137 test yesterday, they had a question that said the sine of 47 degrees equals the cosine of what? Wanting them to know that those 2 were equal. And then the same thing is true for tangent and cotangent. Tangent and cotangent are buddies, they're cofunctions, which means that tangent of 90 degrees minus theta will always equal the cotangent of that angle, and the cotangent of 90 degrees minus theta will always equal the tangent. And we could replace 90 with pi halves, right, if we were in radian mode. So sine and cosine go together, tangent and cotangent go together, and then the last 2 go together. Secant and cosecant also go together. Their complements will also be congruent. So secant of 90 degrees minus theta will be equal to cosecant of that angle, and cosecant will be equal to secant. Again, section 5-1, we're going to repeat this same thing, but I did put a couple questions like this on your homework today, and I'll show you what I mean by that in a minute. But this is the question that wasn't 30, but this is the question like it was on my Math 137 test yesterday. They said the sine of 30 degrees equals the cosine of what? And we could say 60 degrees, because 60 plus 30 adds up to 90. All right. So some of these you're going to be able to do today. using what we did in the last chapter, using drawing a triangle, using SOHCAHTOA, using drawing the picture and label the sides. But also you can use what I've given you today. You can use these reciprocal identities, fundamental identities, to work out some of these, especially like number 3. Number 3, we kind of need to know that identity I just gave you to do that. But it says use the given function and the trig identities to find the indicated trig function. So notice they tell me that secant of theta equals 5 and tangent of theta equals 2 over the square root of 6. And then it asks me to find some of these values. So we could draw a picture here and we could label all the sides here, but the idea is if they give me secant, how does cosine compare to secant? Cosine and secant are reciprocals, right? You look at that front page that we wrote out. We said that cosine is always the same as 1 over secant, right? Or you can just remember that they're reciprocal. That's what we've been doing all in chapter 4 already. If secant is 5, what do you know cosine has to be? 1/5, because you just flip it over, right? Or if you wanted to do it like this, you could say 1 over. The same thing if they give me cotangent. If they give me cotangent, if they give me tangent and they ask me to find cotangent, can I find cotangent pretty easily if I know what tangent is? Because they're reciprocals, right? So cotangent is the same as 1 over tangent. So that's just 1 over 2 square root of 6. And again, I'm okay if you want to leave that. I'm also okay if you want to move the 6 up and then simplify that fraction. I'm okay with that too. But since there's a 1 on top and a 2 on the bottom, like that's not really going to simplify very much more. So I'm okay with that. Okay, so those two aren't so bad. We've kind of done that before. Number 3. The only thing you're going to use those cofunction things for right now are exactly matching it up. Look on the previous page of your notes and tell me what did we say the cotangent of 90 degrees minus theta will always equal. It will equal the tangent of theta. Do we know what tangent of theta equals? Yeah, so if you know that, there's no work to show here. It equals to. So if you see 90 minus theta or pi halves minus theta, the only thing you're using that for is to find what it matches up to. Alright, what about for sine? Sine's a little trickier. You see anything that we could, let's see, sine equals 1 over cosecant, but I don't know cosecant. What else do you see that sine in? Oh, we wrote tangent, right? What did we say tangent can equal? We said tangent of theta equals sine over cosine. Do we know what tangent equals? Do we know what cosine equals? Yeah, so we could plug those in and then solve for sine. You could also use the Pythagorean one, a little bit uglier because it's squared, but sine squared plus cosine squared equals 1. That's the only other one I think that we could do here. So you got to look at what you know to fill that out. So tangent is 2 squared of 6. I don't know sine, but I know cosine is 1/5. Am I going to solve that? When I divide by 1/5, what's dividing by 1/5 the same as? Right? Be really careful on this. Multiplying by 1/5, that would work, right? Because it would really be like divided by 5. Yeah, that would work. Dividing by 1/5 is the same as multiplying by 5, so you need to divide by 5 here, which would work if we just multiplied by 1/5. That would work. I was going to rewrite it as 5 sine of theta and then divide by 5. But either way, look at this. 2 squared to 6 over 5. Kind of building off what we did the first half of chapter 4, using these identities to help us. And if it helps you draw a triangle on something today, feel free to do so. I just want to show you how we do it. Okay, so that's part of your homework today. Gave you some questions where you have to solve for like 4 parts. The other part is where I want you to solve for theta, which is kind of like the extra credit on the no calculator part of that test, where I said solve the equation where cosine equals 1/2 from 0 to 360 and 0 to 2 pi. Right? We haven't really done that yet. If you thought about the unit circle, quite a few people got answers there. But today I want us to actually solve this. So first of all, we're going to do ones that we can do without a calculator, and then we're going to do some with the calculator that we haven't done yet as well. So it says find the value in degrees and in radians given this information. Notice that they tell me that I'm between 0 and 360, and I'm between 0 and 2 pi, which is the normal thing because it's around the circle once. Sometimes it might be more than once. Sometimes it might be different values there. So you always want to make sure you look at that to know, am I in degrees, am I in radians, and what kind of answers can I give here. I picked harder ones than sine and cosine, but if I said secant of theta equals 2, secant is the reciprocal of cosine, so I always like to rewrite that and say that's the same as sine. Right? Because I do better with sines and cosines and tangents than I do with secants, cosecants, and cotangents. And then this is where you have to know your unit circle, or you have to know your triangles, and you have to be able to tell me, where does cosine equal 1/2? What do you got? 60 degrees, so we can say theta equals 60 degrees, or in radians, that would be pi thirds. Is that the only place from 0 to pi where cosine can equal 1/2? Alright, remember every trig function is positive twice and negative twice. Right? 2 quadrants are positive and 2 quadrants are negative. So it's going to be positive again somewhere else. What other quadrant is cosine positive in? Cosine is x, so x is also positive in quadrant 4. If you know your unit circle, it's the same distance away from the x-axis, right? So it means this is down here. So what measure of angle is that? $300 degrees, is that true? Or 5 pi-thirds? Right, this is what I mean about that no calculator part of the test. You have to know these values. Because when we have the next part of our test, there's going to be a no calculator part again, and you've got to be able to do stuff like this. If I go around the circle only once, I will always have 2 answers. Right? I'll have 2 positive quadrants, 2 negative quadrants. In terms of giving answers in degrees and radians, that really means like 4 answers, right? Because 2 are in degrees and 2 are in radians. That's really same thing with this. Where does cotangent equal 1? Well, I'm going to switch that around, even though it's the same thing, and say, where does tangent equal 1? What angle is going to have a tangent of 1? Tangent is y over x, right? So the only way it's going to work is when x and y are the same ordered pair, which is in quadrant 1 at 45 degrees, or my course. And what other quadrant is tangent negative? Tangent's negative over here, right? Because that one, they have to be the same, x and y have to be the same sign. So what other quadrant are? Quadrant 3, because they're both negative, right? A negative and a negative make a positive. So what angle measure is that? $180 plus 45, 225, or in radians, that's pi plus a fourth, 5 pi. right? Having a unit circle today as you do some of these problems, maybe not such a bad idea. To be able to have to know those values. What if it's not from the unit circle? And this is part of, on the homework today, when do I know that I'm supposed to use a calculator, when am I not supposed to use a calculator? Because if they give you a value that's from the unit circle, that means you should be doing that without a calculator. Now look at the next page. Negative 4.3315, that is not from my unit circle, which means I have to use a calculator to do that. And this is a new part for us because we haven't done this without a calculator before. And again, I picked the harder ones of not sines and cosines because it's harder to type this in your calculator than it is for sine and cosine. But I'm going to switch it first. So instead of saying cotangent equals this, I'm going to say, well, let's switch this. And that's the same as saying tangent equals just 1 over that. And I'm just going to write that 1 over negative 4.3. Notice after this it says 0 to 360, which means I want degrees. I don't want radians, which means using my calculator, I'm going to make sure I'm in degree mode. Right? So that's how you know whether you're in degrees or radians. Who needs calculator? So we haven't solved for theta using our calculator. I think you do this in geometry, I don't know. But when you want to solve for theta, you want to get rid of tangent. You can't just divide by tangent. You have to do the inverse of tangent. And the inverse of tangent, the sign for that, a symbol for that is tan negative 1. Doesn't mean it's negative 1 power. That's the symbol for inverse. And if you take the inverse tangent of tangent, you will always get that cancel out. Just like a square root and a square cancels out. Or a plus and a minus cancel out, right? So that's what we do to get rid of tangent, but you have to do that to the other side. So you need to know when you're solving for an angle using your calculator, you're going to use that inverse button, which is usually just second tangent. In degree mode, and you're just going to do inverse tangent of 1 divided by negative 4.3315. So in degree mode, type that in and make sure we can get the same answer. And just use a division bar. Sometimes if you use a fraction bar with a negative, it doesn't like it. I got like negative 12.9999 degrees. Did you get that? So I'm just going to go ahead, even if I was going to round that to 3 decimals, like that's going to round up. So I'm just going to go ahead and round that up to negative 13 degrees because it's 0.99. What's the problem? Oh yeah, it says to give my answer from 0 to 360, but my calculator gave me a negative angle. So how can I make this negative angle a positive angle? Yeah, coterminal angle. All I have to do, right, think about negative 13 degrees is going to be like this direction. All I have to do is add 360 to that, right, to make it the positive direction. So if your calculator gives you a negative degree, which it will, if it's in quadrant 4, you're just going to add 360 to that, right? Which means that we get an answer of 347 degrees. But just like with the unit circle, there's always going to be another answer because every trig function is positive in 2 quadrants and negative in 2 quadrants. And your calculator, no matter how fancy it is, will only give you one answer. You have to know what other quadrant am I in, and you have to understand the idea of reference angles. So, I have my angle right here, that this is 13 degrees away, right? That would be my reference angle. What other quadrant is tangent and cotangent negative in? 2, because that's the only other quadrant where x and y are different signs, right? They're positive here, they're both negative here. So that means there's another answer in quadrant 2 that's going to have the same reference angle. So you have to think about if there's another angle over here And that's why I push reference angles on you so much, even if you use the unit circle, because the unit circle doesn't help you on this. You have to understand that this is the same distance away from the x-axis as this one, which means I know this angle is 13 degrees away from 180 degrees. And could I figure out what measure that angle is going to be? Just 180 minus 13 degrees. So I know that there's another answer that's 180 minus 13 degrees. Or however you want to think about that. Let's send the 167. Your calculator doesn't give you 167, right? You have to know to find that second angle. And you can check that if you want. Well, kind of hard to check cotangent, but I'm going to take 1 divided by tangent of 167, and I'm going to get negative 4.3315 if I round this 4 decimals. Which means you can kind of check your answers to make sure that it works out correctly. But every single angle, whether it's an angle in the unit circle or it's an ugly angle, there's always going to be 2 answers if you're going all the way over the circle. Let's do another one. What about this one? I'm in radians, so step 1, change the radians. Right? If you're not in the right mode, things are going to be bad. Radians, I think, are harder for people because it's harder to visualize that. But again, remember, you can just take pi halves and divide it out to see what the decimals are. Again, I picked harder ones here because sine and cosine, you would just do inverse sine, inverse cosine, inverse tangent. But secant, I'm going to switch it first. Secant reciprocal is what? So this is the same as saying cosine equals 1 over negative 1.3054. And if you want to divide that out, you can, but I always just type it in my calculator like that. And then if I'm solving for theta, I'm going to do inverse cosine. That's how I do an angle out of my calculator. So 1 over negative 1.3054. In radian mode should tell me what angle has that cosine value. So inverse cosine 1 divided by negative 1.3054. And I go to 2 decimal places, 2.44 radians. Did you get 2.44 radians? What quadrant would 2.44 radians be in? I do. Okay. This video is supposed to go to the office and take your car keys. Because this is pi, right? Pi is 3.14. So 2.44 is not more than pi. If you took pi halves, half of pi is like half of this, which is like 1.7-ish, 5-ish, 5.7? I don't know. There you go. Right? And you can just do that. Pi divided by 2 if you want to see what those values are. But that means I don't really care exactly where it is, but I know it's somewhere over here that this is 2.44 radians. Does it make sense? Is cosine normally negative in quadrant 2? Does it make sense that our calculator gave us an answer in quadrant 2? Yeah, cosine's negative in quadrant 2. What other quadrant is cosine negative in? Right, x is negative, which means there's another angle down here that's the same reference angle that's going to have the exact same cosine value because it just keeps repeating itself all the way around the circle there. Because this is the negative cosine, right? Like this is the value we're looking at. Like just like on this one, cotangent was negative, tangent was negative, the value was negative, so we know it was in quadrant 2 and 4. On this one, secant and cosecant are negative, right? If this was a positive number, then we would be in the other 2 quadrants. Just like when we say cosine equals 1/2 or cosine equals -1/2, the value is what determines what quadrant. So reference angle. How do I find this reference angle? Pi minus 2.44, and that's like 0.702. I'm gonna go like that. 0.702, 0.70159 if you want to go with that detailed there. And that means that this is also 0.702. So if I want to find this angle down here, right, I want to find this angle. Can I figure out how big of angle that is? I could just add those three numbers up. I could take pi plus that number, right? Lots of ways I could get there. Pi plus 0.702 gives me an answer of 3.8. So the idea is, where we're going with this, with graphing, is that our unit circle gives us very nice values for 0, 30, 60, 90, and multiples of that, 45. But there's a whole bunch of angles in between there that there are also values for. The graph is a nice, smooth, continuous curve that just keeps repeating itself. What if I said 0 to 4 pi? How many answers would you have if you went 0 to 4 pi instead of 0 to 2 pi? 4 answers, because you just go around and hit those quadrants again. If they didn't restrict my answers, how many answers would I have if it just said find all the answers? Infinitely many, because I could just keep going around a circle, which is why we want it to restrict what I'm doing there. So, I want you to try this one. This. I just added pi plus 0.702. Did you add the three numbers up and get a different answer? Because I rounded. Okay. Because I did the reference angle. Right? If this is 2.44, try this one. Change it to the reciprocal function first. You're going to 1 over. Type it in your calculator. See if you can think about what other quadrant you need to be in and what you need to do to get to that other quadrant. This idea of reference angle. Super, super important. I got 1.13 on my calculator. What quadrant should that be in? 1, and it should make sense. Sine is positive in quadrant 1, so that makes sense that I got an answer in quadrant 1. Right? This was 1.57, so 1.13. Again, it doesn't matter how accurate that is. It just helps me to draw the picture to think about this is 1.13. What other quadrant is sign positive in? 2, which means in quadrant 2, there's an angle with the exact same reference angle, right? So if this is 1.13 away from the x-axis, that means this is 1.13 away from the x-axis. So I'm going to say, how do I find the measure from 0 to 0? What would I do? Does that work? Oh, I think that's a little off, right? Like, wouldn't this, like, this whole thing is pi, and I just don't want 1.13 of it, so I'm just going to take pi minus 1.13, which is 2.01. So there's always two answers if I'm going 0 to 2 pi. Or 0, 2, 3. I'm going to keep doing this throughout the chapter, but I throw this in the end of the section. They just throw into the equation, kind of not ever giving an example for it, which is why I like to spend a day on this, and then we can just continue it as we go through the chapter. So let's do calculator, so we're not calculator. So I'm going to give this worksheet and talk about which ones should be able to do calculator. So the first 6 problems are just like what we did. Notice whether it's in radians or degrees. Notice number 5, I do 0 to 4 pi there to think about. If you were trying to put those in, you can the other answers. Numbers 1, 2, and 6. You can do those with the calculator. 3, 4, and 5. Number 2, you're going to run into a problem. What was that? That would be, right? We'll talk about tomorrow. Now look at 7 and 8. Now that is also 2, 4, 9, and 10. I just want to point out here, those are not multiple choice questions, right? Those are 4-part questions. Those are 4-part questions. Every year I say this, and every year we're trying to know over not multiple choice. Like our first example, where they give you some information and you go. Notice number 7 is about 30 degrees and 60 degrees, which means you can use your uniform all that you want, or you can use your uniform stuff. But that's your good beginning. But on the rest of them, draw a triangle about you. Use those reciprocal identities. Hopefully, it's very helpful to go. We'll go over a couple of these tomorrow. This is 4 days on homework, which means we're not doing this in tomorrow, but that's just we do on a data test, and this will be very for the tomorrow,